Good afternoon. My name is Susan Doyle from Box Media, and I will be your facilitator today. I would like to welcome you to Lean Construction Ireland's 24th webinar, the topic of which is automation in construction in association with Autodesk, and presented by Jaimie Johnston from Bryden. If you have a question, please type it in the question box, and we will consolidate and ask Jaimie in the second half of the webinar. Also joining us for the Q&A session will be Harv Son from Autodesk. So if there are any specific questions in relation to Autodesk, Harv will be able to answer them. If there are any questions that we don't get answered during the webinar, we will follow up by email afterwards. This webinar has been brought to you by Lean Construction Ireland in conjunction with Box Media, their media and communications partner. The speaker for today is Jaimie Johnston, Board Director and Head of Global Systems at Bryden. Having joined Bryden shortly after the practice's formation in 1995, Jaimie leads the adoption of a manufacturing-like approach to creating high-performing assets on projects in the UK, Europe and Asia, with clients including GlaxoSmithKline, Heathrow Airport and several government departments. As Head of Global Systems, Jaimie is one of the UK's leading thinkers on the future of industrialised construction. He was an original member of the UK Government BIM Task Group and was the co-author of the Design for Manufacture and Assembly Overlay to the REBA Plan of Works. Jaimie was the author of the strategy documents, Delivery Platforms for Government Assets, Creating a Marketplace for Manufactured Spaces, Platforms, Bridging the Gap Between Construction and Manufacturing, and Data-Driven Infrastructure from Digital Tools to Manufactured Components. These have been adopted as a key articulation of the UK government's aspiration to adopt a more manufacturing-led approach to construction. This work was reflected in the Infrastructure and Project Authority's call for evidence relating to the proposed adoption of a flat platform approach to design for manufacture and assembly issued in 2018. Jaimie is the design lead for the Construction Innovation Hub, which in 2018 was awarded £72 million to drive innovation and technological advances in the UK construction and infrastructure sectors. I will now pass it over to Jaimie to start his presentation.
Fantastic, thanks for the introduction, and thanks everyone for joining me wherever you are. I know it's always busy straight after Easter, so I appreciate people dialing in to listen, so thank you. Yes, I'm going to talk about why massive shifts we think are almost inevitable now and why the construction industry has to move towards a more manufacturing-like approach, and what we think that might look like. So I'm sure everyone's aware of all of the problems with construction, chronic lack of productivity, aging workforce, all of these sorts of things. We find it frustrating that ours is literally the last industry after agriculture, manufacturing, mining that still just throws thousands of people at the problem in terrible conditions with chronic low productivity. There's a huge number of sort of mental health problems in the construction industry. So we think it's time for a fundamental shift. And lots of people are looking at this, but I think a lot of people are trying to deploy automation to the things that we already do. So someone's actually doing this, putting a huge amount of effort into making a slightly better version of a man with a rake. And you go, surely that can't be the best approach. So at Bryden, we're more interested in not automating the things we do already. It's about starting to look at what would we do ideally if we were reinventing the construction industry from scratch. What would it look like, and how would we deploy automation to that? So it's looking at a slightly different aspect of automation, we think. So over the next sort of half an hour or so, I'm going to cover why we need to look at automation differently, because we don't want to automate the wrong thing, why we think construction platforms, which I'll explain is the key to unlocking this sort of manufacturing-led approach, why we need to then change the design process to facilitate that, how that might manifest itself in the built environment, and I'll touch on how automated assembly might then be deployed on site to make sure that we don't lose the benefits of some of the good work we do in the early stages of projects once we actually get onto site. So at Bryden, we've spent 24 years looking at this problem. We were specifically set up to look at what a more manufacturing-led industry would look like, and how do we get some of that best practice the year-on-year improvements in productivity, quality, safety, features into construction. So you can see here, this is a snapshot of a range of different design for manufacturing assembly approaches that we've taken. You can see here there's no one size fits all approach. There's a whole mix of systems here, from volumetric to panelized, componentized systems. We work with a range of materials: steel, concrete, timber, cold rolled steel. So there's no one methodology which is the right methodology that will crack all of this. There's no one material, wonder material that's going to solve these problems. It requires a sort of a range of techniques and approaches, but we're starting to converge, I think, on what some of those would look like. So we would now confidently say to clients that we will take 30%, 25% out of cost. We'll take 25% off programs. So we've got massive amounts of metrics now to demonstrate that there is a much, much better way of building, of delivering assets. So the obvious question is, if it's such a good idea, why haven't any of these systems or solutions already transformed the industry? Why are we still talking about it? So people very often go to automotive and use that as an example of best practice. I think it's interesting, there was a 27-year gap between the first cars getting patents and the actual massive adoption of cars. So the first cars were very manually made. They were luxury, bespoke items. They did absolutely nothing to transform the industry. The big shift came when Henry Ford started to deploy mass customization. So at that point, the time taken to make a car plummeted, the cost of a car plummeted. That was the kind of the huge shift that suddenly transformed the industry. So I think we're actually on the left-hand side. I think we've got a range of systems that individual companies have deployed. Bryden would have got a number of these systems that are getting massive benefit, but for individual clients. What we as an industry need to do is start to converge on some common solutions and get to the level of scale that really puts you into the manufacturing space, because that's how automotive did. We have to get into that space. To do that, I think we need to start getting, stop inventing our own bespoke systems every time. We need to start adopting more common approaches that are much more scalable and much more adaptable. So the other couple of reasons we think manufacturing has never really taken off for construction, I think this is lots of people's mental image of a construction factory of the future. So, you know, 6-axis robots running around doing things. We strongly believe that this is not the future of construction. This is the mental picture that people have got because they don't have the words to articulate a different vision. So there's a number of reasons why we don't think the future of construction looks like this. Firstly, there's a cost density in cars and phones and aircraft wings. There's tens, hundreds of thousands of pounds packed into a very small piece of kit. Buildings are mostly air and mostly commodity materials. So there's a lack of cost density that means that we'll never get to the kind of level of highly invested automation that you're looking at here. The other one is the scale challenge. So in manufacturing, more often than not, the product is smaller than the process. So if you're making a phone or a car, you can have a robot which is bigger than the phone or the car. If you're building a building, you're not going to have a 200-story 6-axis robot. So we need to get over this sort of thought that we will absolutely do what automotive's done. We will do our own version of it, and it won't look like construction. It won't look like automation. It won't look like manufacturing. But I think because people can't articulate that yet, no one's quite worked out what to do. It's the example that my wife always uses, my long-suffering wife. One of the things that manufacturing does very well is get work in progress close to the point of use. We're really bad at it in construction, but people intuitively know that this is a way of working. So if you go to IKEA, you don't buy a fully manufactured wardrobe and stick it on the roof of your car and strap it on and hope it doesn't wobble itself to bits down the motorway, because you know that's just a daft thing to do. But I think that's what we're doing with some of the volumetric systems. When you go to IKEA, you know that you buy the thing as kit of parts because it's easy to handle and it's easy to transport. When you get the kit of parts home, you don't build it on the drive and think, well, I've just got to get it up the stairs and around the corner and into the bedroom, because you know that's daft. You take the kit of parts to the place where you want the wardrobe to be, you make it there, and then your job done. So people intuitively know that the idea must be to work with kits of parts to get them very close to the point of assembly and then maximize productivity there. So I think there's loads of talk about off-site at the moment, which I think is good. It's a step forward in the conversation, but I don't think the answer is necessarily all about off-site. I think we should be looking at massively increasing productivity on site. Our final point of assembly is the construction site. That's where we need to be putting a lot of effort, because if we're building factories and things to build our buildings, we're just introducing more steps in the process, transportation, logistics problems, and a whole level of additional complexity. So this is why we've started to take the various systems that we've developed over the years and converge them into flexible kits of parts that we call platforms. So we've deliberately stolen the term platforms from the software industry, which uses platforms, and I'm sure everyone knows the car analogy. So BMW, VW, all of those guys, they have a common chassis on which they deploy different wheel sets, different engines, different interiors. So they get a massive level of mass customization, whilst also harnessing complete standardizations. The components and the processes are always very standard, but they can still get high levels of flexibility. My actual favorite example of a platform that's had a big impact is the shipping container. So 1956, Malcolm Clean invents the shipping container. The first shipment that moved things in a multimodal container, the cost of shipping dropped by 95%. Because prior to that, it was an incredibly manual process. You would move things from the warehouse to the dockside, from the dockside onto the ship, off the ship, etc. What the guy did next, I think, is fascinating. So he open sourced the twist locks at the corners, which is the thing that really makes the system work, and all the dimensions. People thought he was crazy because he was sitting on a potential gold mine, but his view was, if I give this stuff away, I will own a much smaller slice of a much bigger pie. What he didn't see coming was then you get ships and docks and cranes and software. You get a whole digital, physical infrastructure that makes this work incredibly well. The result is that we have a global economy, supply chains are very long, global diversity, global economics works much better. So that was a little piece of standardization, a bit of open sourcing, and it's fundamentally changed the economics of the world. So I'm not saying we can have necessarily that impact immediately, but I think that's the sort of thing we should be emulating. The other one was that iPhone sales, when they first started, were actually relatively poor because Steve Jobs didn't want third-party people putting stuff on his phone. Literally the quarter after they opened the App Store, sales went up tenfold. It was the growth of the app, or the birth of the app economy, which is now worth trillions of dollars. Sales on the App Store alone will be bigger than global box office receipts over the last couple of years. So again, a bit of standardization, open sourcing, lots of people join the party, and it transforms the way that we do things. So we did a thought piece for the UK government. So I've worked with the government for a number of years now. We said, we reckoned if you plotted every space that government buys on this graph of span of spaces and heights of spaces, probably everything that you buy would sit on this graph somewhere, and they would probably cluster themselves into a kind of small scale residential type spaces, mid-span healthcare, education type spaces, and big empty shed type spaces. One of the things we said to them is one of the problems that government has is they have an enormous pipeline of spend, but they still drip feed it into the markets. The fact that government buys £1 billion worth of schools, £1 billion worth of hospitals, £1 billion worth of education is a bit of a problem. As an industry, we think too much in terms of sectors. If you started to unpick the kind of fundamental DNA that underlies these buildings, there's not a huge amount of difference. Our guess was that if you had a small scale platform, mid-span platform, large span platform, that would do most of government procurement. And we've actually since proven this and started to overlay the real pipeline of spend. And we're starting to demonstrate that billions of pounds worth of construction could be done with a really small number of components, which would instantly get you into the sorts of numbers that manufacturing talks about, and it would start to transform the way you think about these things. So over the last couple of years, we've been working very hard with government on this. It started with the book. Top left, you can see we set out this position that government could get massive benefit from adopting this strategy. That was certainly influential in the autumn statement 2017. It was then followed up with the construction sector deal, House of Lords get involved. And on the right-hand side, you can see in the same week, last November, IPA put out a document, this proposal for a new approach to building, which they call a platform approach to design for manufacture and assembly. So government has now really clearly said, actually, platforms is what we're doing. The Construction Innovation Hub is how we'll deploy it and how we'll test it and scale it up. So I think that's a fantastically good news story, that despite everything else that's happening in politics at the moment, government's been incredibly consistent in its message. It's been putting more and more granularity behind the message, and it's saying very, very clearly, this is what we're planning to do as we deliver the public sector spends. This was an excerpt from the IPA document. It says digitally design components, multiple types of assets, and apply them wherever possible. For example, a single component we use for a school, hospital, prison building. So they've taken this on board, and they are really moving this forward now. One thing I thought was interesting, this call for evidence, it wasn't saying, we're looking at platforms, I wonder if that's a good idea, what are the risks, what are the benefits. It seemed to be saying, we're doing this, you have an opportunity to join the debate, but we're going to be doing it, which I think is a very strong position. And it amazes me that people haven't sort of picked this up as much as perhaps they should have done. You can see here the key principles they're talking about: design for manufacture, use a platform approach, and again, open for manufacture use and procurement. So one of the things we've promoted is this idea of open sourcing, making this stuff as widely available as possible, just as they did with the shipping container, lowering the barriers to entry. So the more people start to get behind it, the more people get the benefit, and the more you start to build this momentum. So we've actually developed and tested a number of these platforms now. I talked about the 3 types, the small, medium and large scale platforms. We've actually physically built and tested them all now. This is platform 2. So things I would say to note: bottom right, you can see the finished superstructure on platform 2. It's not unusual in any way. Steel beam, steel columns, concrete slabs. The end result is actually really, really normal. There's nothing unusual about it. There's no strange materials. There's no strange manufacturing techniques. So the end result is actually pretty standard. The way it gets there is very different. So if you buy a box section from Tata Steel, say, it's about £800 a tonne. If you buy a fabricated steel frame, it's about £2,500 a tonne. So the thing you wanted was the performance of the steel. The thing that you pay for very often is all the transactional costs and logistics and the movement and the fabrication and the double handling from the manufacturer all the way onto site and into final assembly. So we literally buy square hollow sections and have them brought to site with one hole punched or laser cut. On the left-hand side, you can see a set of standard brackets that we use for all of the connection points. So there's only a limited number of bracket types, but they do every connection: base connection, beam to column, end joint, etc., etc. The first time we bought these brackets, they were, I think, about £8,000. The next time we bought them, we got them from a very small, very local company who specialise in CNC laser cutting, who did them half price. So we're now buying commodity things like box sections direct from a manufacturer, brought to site. We can buy the highly fabricated components from a super wide, resilient SME, very local supply chain, have them brought to site. And then these are assembled. This one happened to be up at a prison site that I shan't name, using Prison Industries. So you can imagine the length of the beam and the column can be anything you like. So we've instantly got that kind of mass customization and ability to do very specific things. To the guys on site, it's a yellow bracket, which means I need a torque wrench, X number of bolts. So the assembly process is incredibly standard. So we're now talking about buying components direct from manufacturers, using a completely different supply chain, using a completely different skill base, lowering the skills needed. So just like Jaguar Land Rover cars aren't made by engineers and mechanics, they're made by people who've been trained to assemble these things. We can now assemble major pieces of infrastructure using low-skilled personnel. We build pharmaceutical facilities. We built with ex-Gurkhas, so ex-service people. We've built pieces of Heathrow Airport using people from Crawley Job Centre. We're now building MOJ facilities using Prison Industries. So we're completely changing the people we need and the skill set, which is a fantastic, I think, thing to be doing at a time when we're talking about skills gap, we're talking about aging demographics, all the rest of it. The fact that we don't need construction skills, we can suddenly be deploying a completely different skill set, massively diversifying the construction workforce, tapping into unemployed ex-services, ex-offenders, all the rest of it. Suddenly there's a massive social return on investment that comes along with this for nothing. So what do we get out of it? This is data from one of the government departments. Having pushed the use of BIM, the use of lean, working closely with their supply chain, their figures suggested that of every pound they spend, only about 50% ends up as residual asset value. The other half disappears. Some of it into very positive things like profit in the supply chain. A lot of it into, you can see the second biggest thing after product is client risk. This is overheads, it's waste, it's rework, it's transactional costs. So it's really non-value adding work. So again, one of the things we're saying to the government is rather than try and reduce costs by squeezing a few percent out of the supply chain, and they will hate you and they will claw that money back through change orders and things. A better thing to do would be to make sure people are paid well, make sure profits are sensible, to enable the right behaviours, but you would take out the chunks of cost from all of this transactional non-value adding work. So Turner Townsend did a piece of work. They weren't involved in the design of the platforms. They came and did an objective analysis for us. Firstly, because obviously they bring a huge amount of experience. Secondly, having that objective testing meant that they weren't subject to maybe the optimism bias that we might have had. But they came back and said, yeah, looking at the benefits of this, there's a sort of up to 33% reduction in capital cost. We're assuming, by the way, that whole life cost is better anyway because of the performance of the buildings and all the rest of it. But if you can win the capital cost arguments, you don't even need to talk about the whole life cost. So we're not suggesting we would take 33% day one. What it means is there's a huge amount of benefit that could be returned to clients and a huge pot of cash that's available for training and upskilling and all the things that need to happen to make this work. KPMG did a similar study on one element, the facade system that we developed for the MOJ. You can see here their numbers compared to traditional precast. This facade system is about 50% cheaper. At the same time, it was tested by Prison Industries, so you get 50% cheaper facades, while at the same time creating new jobs, creating new skills, creating opportunities, helping to rehabilitate, all the rest of it. So you get massive cost saving with huge social returns. So how do we do this? I've talked about open sourcing a few times. We have this written into our contract with the government. Anything we design for them, they instantly get a completely free license to do with whatever they like forever. So we're effectively open sourcing all of this. So again, our view is that there's no point us doing this for our clients and retain the benefit. We need to make this available. So in my view, this is what the Construction Innovation Hub will help us to do, is take the things that we've already developed, put behind them all the kind of the proper warranties and the manufacturing processes and all the kind of certainty, and then give it to the world and make sure that everyone has access to it. So I think there's a phenomenally exciting time coming where suddenly lots of people get access to this stuff, and people that couldn't necessarily invent the system from scratch could deploy the system and start to get into those sorts of numbers that we've talked about. We're talking about much more close engagement with the supply chain. So when we did that platform to superstructure, we point cloud scanned it, and the furthest anything out of tolerance was 3 millimeters. So we're talking now in the sort of 2-3 millimeter tolerance, and that was a bit of an outlier. There's loads of innovation in the facade supply chain, for instance, but half of their life is fixing the gaps between their millimeter perfect unitized system or precast systems and then the wobbly traditional frame that sits behind it. So as soon as you get into that kind of level of precision, there's suddenly loads of really good practice in the supply chain that instantly comes to the fore. And the fact that we're now having discussions between major clients and very small manufacturers means that we're now starting to close down all of these long supply chain transactional things. We're starting to bring manufacturers much more closely into the conversation. This is one of the things that government recognised fairly early on. If you're a single program of works, you look like the top one. So lots of schools, no schools, lots of schools. Or if you're a manufacturer, this is what your pipeline looks like, where you sort of boom and bust. I think people are recognising now that if we started to use common components, then the peaks and troughs of all the different programs buying them would start to average out, and you'd start to get a kind of baseline of just a fundamental need for the same components. So if government did this, it would start to get the economies of scale that everyone would like to get their hands on. The manufacturers, if they could start to see a consistent pipeline, would then have the confidence to gear up, to start to invest, to start to meet people halfway. So again, pipeline is one of the things that always gets talked about. We think this is a way of achieving that pipeline. Even the major programs, even Heathrow expansion and the like, doesn't have a long enough, persistent enough pipeline to change the industry. But if we start buying these things centrally, then we start to get the kind of persistence that we need. Logistics is going to be a huge thing for lots of the big programs moving forward. So if you buy a volumetric solution, you can get about 110 cubic meters, give or take, on the back of a truck. We can fit about 5,500 cubic meters worth of superstructure for Platform 2 in a single 40-foot shipping container. So if you're HS2 Euston, or if you're Heathrow expansion, or any one of a number of other major projects, you are all about logistics. So the fact that this is designed for few vehicle movements, very controlled logistics, brings immediate benefits. One thing that we often get people ask about is this: why aren't you doing people out of jobs with this sort of new ways of working? Actually, what's persistently happened through history is that every industrial revolution, we lose certain jobs, but it creates more new types of jobs. So I think we're at a point where, given that the problem we've got is we have a massive skills gap, aging workforce. IPA talks about a £600 billion investment in the next 10 years. UN talks about 2.5 billion more people living in cities by the year 2050. Our problem is not that we're going to do people out of jobs. Our problem is we don't have anywhere near enough people to possibly keep up with that pipeline. If we don't start doing things in a radically more productive way, we simply can't keep up with the infrastructure needs that the world has. So the problem is that we need to start adopting these things and find new ways of working. So that leads on to automated design. So if we have these digital components that understand how they relate to each other, it means we can start to use the rule sets and start to automate the design process. So what do we mean by automated design? There's lots of iterations or lots of versions of this. This is where we think we're heading. So one version of this is we could use these rapid tools. We could start to automate things. We could use Dynamo and script lots of our tasks now. One version of that is to do the same thing but quicker, which is fine, and it's a good use of the tools. A more interesting thing, we think, is to do a quicker thing but also a different thing. So if you knew you were going to use these design tools and you were going to start to automate, maybe you would do something fundamentally different. So this is, I'm sure everyone's seen a version of this slide. Currently, BIM is the kind of the central single point of truth. It's the kind of central model around which everyone views. We think this is it was a fantastic start to a conversation, but BIM was never meant to be the destination. It was a direction of travel. I think now that the industry has broadly adopted BIM, now that people are sort of starting to really use it to its potential, we're ready for the next view of it. We think the future will be BIM will be one of the lenses through which people start to use big data. But we're going to start to use generative design, algorithmic simulation, mathematical modeling. So I think BIM has been a sort of stepping stone onto a path of greater digital transformation. And I think these tools are going to start to get better and better, and our toolbox of design capabilities is just going to get bigger. So we have a team here, creative technologies team, who spend a lot of their time developing specific apps for clients, trying to find ways to use these digital tools more productively and create sort of better design solutions. So I'm not going to talk through all of these. There's a number of things we're working on at the moment. One's a configuration tool for prefabricated schools. We're going to publish that, I think, next month, but we're going to open source it, publish the code. It'll be a web-based workflow, so you won't need to buy the software. We're doing the same thing for GLA in London for precision housing. That's going to get launched end of June. Again, we're publishing it. We're going to make it completely available. We've done a piece of work for Highways England I'm going to talk about, and I'm going to show you where we think some of the end state of this is heading. So this is a piece of work we did for Highways England. It started out as the initial ask was to create a BIM library for the Smart Motorways programme. But working with the Smart Motorways team, we found that there was loads of opportunities for more digitally enabled ways of working. So we found, for instance, that the gantries were designed from scratch each time. So somebody would actually create a parametric model that as you place the gantry and size it, it automatically sizes the structural elements. We then taught each of the different assemblies, so in emergency refuge areas and gantries and things, how they related to each other. We then took the highways technical standards and codified them and put them into an algorithm. We're now at a point where we have an algorithm which takes a stretch of motorway. So you tell it which bit you're interested in, it pulls that out, it automatically analyzes it for a number of features. It starts to analyze it according to its curvature, gradient width, visibility, all the rest of it. It then gives you an automatic score and says, here's how readily adaptable this stretch of motorway is as a smart motorway. Then, because it knows what context each component's looking for, so an emergency refuge area wants to be on a long straight piece of road without too much gradient, it places all those components, optimizes them relative to each other, then analyzes it for all of these environmental things, tweaks the positioning of the components, and spits out a incredibly quick but reasonably accurate, or very accurate but sort of early stage design for your smart motorways, which you can then take out and then you can analyze it and you can test the positioning of all of it. So every time we do it, obviously we don't, if we find a problem, we don't correct the model, we correct the rule set, and it gets better and better and quicker and quicker. It generates a huge amount of data for different stakeholders. You can automatically drive down the road, etc. So this is the workflow which has changed the way Highways England think about the design process. It's about 95% quicker than the human teams for the same stage. Again, that's not doing lots of people out of work. It's now freeing up a load of design time for people to spend on the really complex bits, which are all the junctions and the interactions, which are very, very hard to write an algorithm for. So again, we're not deploying fewer people, we're deploying the same people to do more work or more creative work or put more effort where they should have it. This is our tool set we're developing for platform buildings. So where we have repeat clients, we're able to generate a whole range of solutions for them. So rather than design one or two concepts, we can now create every single concept that works within the rule set. And we can then pick from a range of solutions and say, well, which one takes up the least site, which one takes up or requires the least amount of access, all the rest. So rather than design one or two concepts and test them, we're now picking from a range of every concept you could have on a site. We can then obviously we use a huge amount of tools like Dynamo to automate some of these things. We can then deploy machine learning on top of that to output, again, a whole range of different solutions and start to learn which one's the best. Once we have those models, we've got another set of algorithms that take the model and start to automatically create the BIM models straight out of that rule set. So you can see the speed with which we can now go from a brief to an optimized site layout to a fully quantified, fully manufacturable model is incredibly quick. What it's doing is allowing us more time to spend engaging with the client at the front end, really understanding the problem statement, really understanding where we can add value. So increasingly we're changing our value proposition and spending more time on we think, creative value-adding steps. So this is leading us to a whole range of different solutions. As I say, we think platforms is the kind of key thing that's enabling all of this convergence of manufacturing, construction, automated design, but without compromising on architectural quality. So again, just as the automotive industry does a very good job of mass customization, we think there doesn't have to be in any way or shouldn't be a compromise between architectural quality and the adoption of all of these advanced tools. In every other sector, we associate automation and manufacturing with high quality design, with beautiful looking things in phones and cars. It should be exactly the same in buildings. And I think we're starting to see a shift in people's perception. I think people are recognizing that actually traditional build quality isn't fantastic. Use of this sort of manufacturing technique should result in very, very high quality, beautiful, high performing buildings. But the key to that, we think, is design. It's all about design. So very often we hear this term design for manufacture and assembly talked about as the product. I think people forget that it's the process. So if you wanted to manufacture and assemble your buildings, you would design them differently. So again, this isn't diminishing the need for design. It's just a different type of design, but it's a much more, we think, a kind of much more holistic approach. Architects used to be the master builders, so we think this is quite an opportunity for people to reframe what design looks like in terms of our assets. So the most value-adding thing a person can do is have the idea, is develop the concept. That takes a fraction of the time, but it's the real value-adding step. The thing we currently get paid for is documenting that idea. So we get paid for drawings and deliverables and documents and all the rest of it. The stuff on the right-hand side is about to evaporate. So you can see from the tools we're talking about, the time taken to develop the design, create the model, etc., is just disappearing, which is fantastic news in some respects, because as I say, it's given us more time to spend on the front end, but the commercial model hasn't caught up with that yet. So I think there's some really big shifts coming around the use of automation. I don't think we have all the answers yet, but it's a conversation that I think as an industry we should be having. My fear is that we will take all of these fantastic new technologies, all these fantastic new tools, and we'll end up designing things that look like they were made in really traditional ways of manufacture. So if you look at the history of architecture, actually it's one of technology. So we couldn't build tall buildings until we got the hang of using steel in a particular way. We couldn't build them much higher until we got the hang of lifts. High tech was a response to using glass and steel in a particular way. So I think the conversation we should be having is, if we were using these tools, if we were using these manufacturing techniques, if we were bringing all this stuff to bear, what would it look like? I don't think there's any reason to expect that the buildings of the future need to look like the buildings of the past. I personally think there's a really exciting opportunity now to say, well, if we started to really deploy all these tools, what does our built infrastructure look like? If we can make things that are much more flexible, repurposable, if we can use automation on site, if we can reduce numbers of people, what does that look like? We should be having a chat about what the future of our built infrastructure looks like, because my guess is it won't look like the buildings of the past, but I don't think anyone knows what it looks like yet. I think if we don't start to really engage with this, it will happen to us and we'll have missed probably the biggest opportunity that's going to present itself in the near future to our industry. So if that's of interest, as I say, there's a number of books we've published on this with the UK government, with the University of Cambridge. They're on the website. You can download them. If that's of interest, I would encourage you to have a read them. I'm massively biased, but I think they're quite an interesting read. It sets out a lot more detail about this approach and some of the considerations that sit behind it. So I will now hand back, and hopefully there's some questions. Thank you.
Thanks, Jaimie. That was a very insightful presentation. Yeah, we have several questions, so I think we should just kick into them if you don't mind. Question one, who do you think will be the contractors of the future? Will the major delivery organisations be the existing tier ones or someone else?
My absolute guess is it won't be our existing tier ones. I'm sure everyone's seen the statistics about I think the major tier ones over the last couple of years have on average lost money. They're minus 0.9%. Obviously we've had Carillion, trouble with Interserve at the moment. So my guess is, if you looked into the future, what this needs is someone who's good at logistics, primarily logistics, procurement, supply chains, digital. I think maybe one or two of the existing tier ones will get their heads around this and start to shift into a very different space. I don't think it'll be Amazon, but Amazon are good at logistics and procurement and supply chain, all the rest of it. So it wouldn't surprise me if there's a number of people who are just outside the industry watching this with interest, who wouldn't touch construction because it's so bespoke and it's so unproductive and it's a basket case. But if we suddenly started doing this, we'd go, yeah, I could do that actually. In fact, I could do that a lot better than you. I mean, we live in this world where disruption happens all the time. So Netflix and Airbnb and Google, we live in a world where people from outside a sector come in with a slightly different approach and take over very, very quickly. It wouldn't surprise me if something like that happens in construction, that someone unexpected turns up and overturns it. And my guess is it won't be one of our existing tier ones, but maybe some of them will shape up for this.
Okay, interesting. Another question from one of our attendees. What would you say to a general contractor that's thinking about creating their own siloed IC platform supply chain? How can they collaborate with others in the industry to open source the platform and standardize for the benefit of the industry?
So I'd say certainly don't invent your own system. I think we've watched this endless times in the industry. There's lots of people who've got very, very, very similar systems, but they're slightly different from their competitors, and it's a problem for them. So one of the pushbacks the volumetric manufacturers get sometimes is the lack of interoperability. So there's a nervousness from the market that if they're halfway through a project and they go bust, no one else can step in. So I think that kind of shipping container analogy of those guys starting to converge and starting to share knowledge actually wouldn't diminish their market share. I think if anything, it would start to broaden them. We are aware of, I'm not sure we can name them, we're certainly aware of a few volumetric people who are now coming together and starting to share systems and starting to share their ways of working for exactly that reason. I think for people starting on the journey, the Construction Innovation Hub would be a first port of call. So it's early days yet. It's only just started to find its feet. But I think that will be, I'm hoping that becomes the kind of central point of, if you want to engage with this, if you have a system that you want to share with people, that's the point. If you need a system and want to see what everyone else is up to, I'm hoping that becomes the forum for that sort of conversation.
Okay, great. Another question from our attendees. Is the platform-based system design available as open source data?
Not yet, only because we've done the first things with the Ministry of Justice. We need to go through a sort of a process with. So the Construction Innovation Hub, for those who don't know, it's brought together Manufacturing Technology Centre up in Coventry, who know a huge amount about aerospace and automotive manufacturing, Cambridge Centre for Digital Built Britain, who bring all the sort of digital smarts and digital twin type smart infrastructure work, and BRE, who bring the kind of testing and assurance. So at the moment, we're more than happy to use these platforms for our clients. I think before we completely send them out into the wild, there's a whole number of questions that people have around warranties and design liability and effectively product recall, all of those sorts of things that we need to nail out or iron out with MTC before we make them available. But yeah, we haven't protected any of the stuff we've ever done. So there's nothing to stop people replicating exactly what we've done. We'd encourage people to do that. We think that'd be quite interesting. Our clients like GlaxoSmithKline, for whom we've developed particular systems, have always encouraged other people to use them, because they've said if other people use them, I would just get my pharma facilities much cheaper, which would be better. So we haven't formally published all the components yet, but we haven't done anything to try and protect them. And I think through the Construction Innovation Hub, we'll be trying to properly open source them and properly make them available. And that's going to happen, I think, very, very soon.
Okay, brilliant. Another question. The questions are coming in fast now. How can IoT be used in conjunction with the BIM for making construction more like manufacturing?
Oh, that's a good question. That's a really good question. Yeah, there's a slide I sometimes use that shows the number of things that will be connected to the internet over the next X number of years. And it goes up exponentially, and that's not more smartphones and PCs. That's all IoT devices. I think there's an incredible thing that's going to happen. So obviously things like phones and laptops are, I would say, passive, because information flows through them. They don't change anything. IoT devices will change lighting, change heating, open, close door. So I think they're sort of operational things. I think there's a really interesting space that we could get into where buildings start to become self-optimizing. So you can imagine putting a load of IoT sensors into a platform type building, and it's starting to work out how people use the building, and firstly feeding that back into the next iteration of models and saying, I'll tell you what's a really good configuration of components for an office is this. Or starting to kind of self-optimize and say, right, I need to change the lighting, I need to change this thing, and telling you what to do as the building evolves. So I think, again, the way we currently build buildings, there's nowhere for that IoT data to go. So all it does is tell you how your existing asset is performing, and you're going, well, great, because maybe I can tweak my existing asset. It doesn't move you forward. I think the lovely, or one of the good things about platforms will be this kind of feedback loop that we could use the IoT sensor data. It could tell you something really insightful about our assets, and you'd learn something for the next iteration and the next iteration, the next iteration. So we'd start to get feedback loops that will make us better and better and better. So again, I think that's one of the really interesting things about this sort of future infrastructure. Do we start to make buildings that are kind of blank canvases that start to tell us how they should be used and start to self-optimize? I don't know. I think that's a really interesting space. But again, I don't think anyone's properly understood that.
Okay, excellent. Another question. Do you employ design economics in your design automation?
What do you mean by design economics? I'm not sure what that term means.
It's a question from an
design costing. If it's costing data, then yes, not complete costing data, but one thing so for the individual components that we know the cost of, all of that cost data is attached. So it will output a very accurate sort of bill of materials, but only for the things it understands. It doesn't know about, things like foundations and all the rest of it. It is starting to change the cost conversation where we say to the QSs, right, these bits you don't need to look at because they come straight out of the model. Your job is now to validate the costs we've got for the components and the relative value of all these things and cost the difficult bits that we haven't modeled. So it's starting to change. And as you see, TNT are sort of embracing this and starting to work on what the future kind of cost consultancy looks like in that sort of space. We do have, in our office now, we do have data analysts and financial planners and economists and chemists and a whole range of other people. So I'm not sure if I've answered the question that they asked, but hopefully that
okay, yeah, absolutely. This is kind of a longish one. Coming from an estimator QS background, do you see a worldwide industry rules of measurement or the use of Uniclass, etc., so everyone is pricing and estimating on the same level and coding for material and labor, etc.?
I really hope so. I really, really hope so. Yeah, we've been pushing very hard to get everyone to use Uniclass. It's not perfect, but it's probably the best thing we've got. Yeah, one thing that I didn't talk about, but one thing we've started encoding in our components is not only the cost of the component, but also the skills needed to assemble it, the labor, content. So for some of our clients, we have very dynamic models that as quickly as you're modeling a thing, it will also tell you how many people, what type of equipment, what type of machinery, cycle time of certain activities. So yeah, I think if we could get that consistency of naming convention and all of that coding stuff, that would be a massive step forward. If we could get in my head, sort of platform components, you could imagine a sort of currency of labor skills and things attached to them. You can imagine across major programs, as quickly as it's telling you the cost, it's also telling you what type of skills you need and where, and you start to then use it for the sort of social purposes. So yeah, I think if we could get a real commonality of that sort of currency for lots of different things, it would be a fantastic way of moving forward. Yeah, universal currency for all types of cost and carbon would be fantastic.
Yeah, absolutely. Another question now, how researchers can contribute to platform approach and Bryden Wood?
Again, I think it's through the Construction Innovation Hub is probably the best port of call. So there's as you said at the start, there's £72 million been awarded. A lot of that is going to come out through Innovate UK competitions. So there's already been the first round of collaborative R&D, whenever that was, end of last year, start of this year. So there's already been the first round of competitions. We'll be shaping up the competitions moving forward. And one of the things we'll be doing is framing a load of questions that need answering. So to say, I think I'm not suggesting by any means that everything I've showed you is absolutely the right answer and absolutely where we need to be. We're hoping it's the sort of start of the conversation that people will contribute to. So through the CIH, we'll be putting out, framing a load of questions and going, right, we don't know enough about IP, design liability, warranties, IoT performance, all of these things. So there'll be a whole series of competitions. So I think if anyone's got an interest and wants to contribute, that will be the forum to do it.
Okay, brilliant. Another question. What % of buildings are constructed using this approach today? What stands in the way of wider adoption?
So currently it's like a tiny fraction of a percent because it's only the ones that we're working on. So yeah, it hasn't been done at scale. The thing that's stopping it, I think, is the way we procure assets at the moment. So I don't think there's any technical issues with it. The problems are all about the culture and the blockers and the way we incentivize people. So two-stage D&B doesn't work well for this because it puts a client talking much more directly to the manufacturer. It cuts out a lot of the kind of the tiers. So we're talking about getting components direct to site assembled by the fewest number of people in the quickest way possible. That's incredibly value adding, but no one's geared up to do that at the moment. So it's the way we procure things, it's the way we incentivize people, it's the way the industry is set up. That's the big blocker. And it's the thing that stopped us a couple of times from doing this at much greater scale is some of the incumbent players just aren't interested in this because it doesn't align with their business models at the moment. So a bit like BIM, BIM was much more of a cultural shift than it was a technical one. The technology existed for a long time. I think we're now looking at a kind of cultural shift.
Okay, just a few more questions, if you don't mind. How can design automation connected to product platform development in a company?
Say that question again.
It's just from an attendee, so it's been typed in. How can design automation connected to product platform development in a company?
I'm not sure I've quite understood the question. So the way we've worked on it, as I say, we've developed a number of, I wouldn't say bored of it, but we developed a whole load of systems for different people, and we started to recognise that there was a sort of increasing level of commonality, which kind of led us down the sort of the DFMA bit of it. We then recognised that to do it properly, we needed a sort of increasing digital skill sets. So we've started to kind of broaden the range of people that we're using, and I think we're now becoming maybe a bit of a magnet for the sort of super digitally enabled people with more of a coding background, product design background. So we're finding actually it's opening up the skill sets of people that we employ in the office, the types of people that we employ in the office, and it's constantly changing the way that we work internally. Again, I'm not sure I've answered the question.
Okay, I think we're having a little bit of interference there, Jaimie. It's a bit squeaky. So we'll try one more question. Is there any constraints on the platform-based system in terms of height, facade systems, etc.?
Good question. We've designed them up to 25 stories. There's no theoretical limit, but no one's asked us to go over 25 stories. The superstructure is designed to work with any type of facade system. So we can tweak the wall thickness of the columns, we can tweak the edge thickness. So yeah, there's no practical limit on height. There's certainly no limit on the type of facade systems we'd employ.
Okay, perfect. I think that's it in relation to questions. There's a bit of interference on the line there. So, Jaimie, thanks a million for the presentation. A copy of the webinar will be sent out to everyone who attended. We'll send out information shortly to the next webinar via LinkedIn, Twitter, and newsletter. Thank you again from Jaimie Harv on behalf of Lean Construction Ireland. You can follow Lean Construction Ireland on LinkedIn, Twitter, Facebook, website leanconstructionireland.ie. Enjoy the rest of your day and be lean.
And thank you for listening.
Thank you.